In this video, we'll take a look at solving a system of equations using fractions. We will be using the elimination method for this problem. So if we look at our first equation, 1/5 x plus 1/2 y equals 3, we'll notice we have fractional coefficients. The first thing we want to do is an option. We can get rid of the fraction altogether. We do that by looking at our fractions and finding the lowest common denominator. So in this particular question, the lowest common denominator of 5 and 2 would be 10. So we're going to go ahead and multiply the top equation here by 10. And we'll see what that does with our fractions. Remember that when you're multiplying a whole number times a fraction, we really have a 1 underneath that whole number, and we're multiplying straight across the top. 10 times 1 is 10. 1 times 5 is 5, and then we should be able to divide. 10 divided by 5 gets us 2. We've just eliminated that fraction and we end up with 2x. Let's do the same thing with 1/2. We again have 10 times 1/2. Put a 1 under that 10 and multiply straight across the top. We'll get 10. On the bottom we'll get 2, and 10 divided by 2 is 5. So we now have 2x plus 5y equals. We also have to multiply 10 times 3 to get 30. We'll do that same process for the second equation. Notice this time I have two fractions, but they both have the same denominator, a 3. So that would be the least common denominator. So I'm going to go ahead and multiply both of those equations by 3. And I'll put that work over here. Again, we have 3 times 1/3. Put a little 1 under that 3 and multiply straight across the top and the bottom. We get 3 over 3, which is 1. So our new x value, our new x coefficient is just 1x. We have 3 times -2, that's -6y. And then we have 3 times a -2/3. I'm going to put a little 1 under that 3. 3 times a -2 is -6. 1 times 3 is 3. -6 divided by 3 is going to give us -2. So that equals -2. So these in my box here, these are my two new equations without the fractions. From here we go ahead and solve our system of equations like we've done before. I want to find opposites in my coefficients. So I look at my first equation, I have 2x. My second equation, I have 1x. So I can go ahead and multiply this second equation, and I'm going to switch to orange. I'm going to multiply that second equation just by a -2. And that will create those opposite coefficients. My first equation is going to stay the same. That's going to be 2x plus 5y equals 30. My second equation is going to change into -2x. -2 times a -6 is going to be a positive 12y. -2 times -2 is a positive 4. Now we can go ahead and add up our two equations using that elimination method. Our x variables will cancel each other out. We'll add up our y's. I have 17y equals 34. And divide by 17 on both sides. We'll get a y value of 2. Now remember, when we're solving a system of equations, you need an x and a y value. So here I'm going to set up my solution. So far I have my y value at 2, but I need to find my x value. Now it's your choice whether you plug this y value of 2 into one of the original equations with the fractions, or maybe one of the original or the newer equations in the box here in red. I think I'm going to place my y equals 2 in for the top equation in my red box here and see what that gives me. So again, I'm not working with the fraction because I've eliminated it. Hopefully we've eliminated it correctly for everything to work out. So once I substitute my 2 in for y, I'm going to just go ahead and solve this equation. It's a two-step equation. I'm going to have to subtract 10 on both sides. And then divide by 2. I'll get my x to be 10. So my solution to this system of equations should be 10, 2. Again, you can work with the fractions or you can eliminate the fractions by multiplying by that least common denominator.